Hi class, we're looking at direct variation and inverse variation now. So remember yesterday's lesson was on direct variation and we said that y equals k times x, where k is a constant value. So y is said to vary directly with x. Y is directly proportional to x and the ratio of y over x is the constant. We like to call that constant k. Now with inverse variation, okay, notice that the direct variation here, we have a straight line and it goes through 0. Okay, so this is a linear relationship. We have that constant value right here and it goes through 0, 0. However, with our inverse variation, y equals the constant divided by a number. And so you get this half a U-shaped graph here. It's not a parabola. It's an inverse graph is what we call it. And so y is said to vary inversely with x, and y is inversely proportional to x. And the product of x and y is the constant here. So an equation in the form x times y equals k, or in the form y equals k over x, where k is not 0, okay, is an inverse variation. The constant of the variation is called k. So let's put this information to work for us. So in this problem here we have 2 points, 5, 6, and then 3, and we have a missing number. And we're told that it's on a graph of an inverse variation. Remember, with an inverse variation, we have the product of our x and our y is always constant. So we can say 5, I might have this typed up, apologize. Yep, here I do. 5 times 6 should equal 3 times y. And then we can just solve and we get 10. So y is 10. That is the missing value here. And you can see 3 times 10 gives us 30, and so does 5 times 6. That is just further proof that this is an inverse variation. Moving on to example 2. So now we're going to apply this inverse variation here. Jeff weighs 130 pounds and is 5 feet from the fulcrum. Tracy only weighs 93 pounds, so we're going to have to place her in a different spot to balance out the lever. And again, I can't wait till you guys get into your physics unit with Mr. Beerley and to be able to put some of these information into action. So we know that the weight of 130 is 5 feet from the fulcrum. And then 93 is x feet from the fulcrum. And so remember, the weight and the distance vary inversely. And so the x times the y should equal another x times the y. So if we have the weight of 1 be 130 and the weight 2 be 93, the distance 1 is 5 feet and the distance 2 is x feet. We can write that weight 1 times the distance should equal weight 2 times its distance. We can plug in 130 here for the weight of weight 1 and 5 for the distance from the fulcrum. 93 is Tracy's weight. We can multiply and divide and we get about 6.989, so almost 7 feet from the fulcrum. Tracy should sit to balance out Jeff's more weight closer to the fulcrum. Okay? Let's look at example 3. We want to determine if it's a direct or inverse variation. The neat thing is with direct and inverse variation, okay, remember, direct, we should be able to take y and divide it by x and get the same number. So 10 divided by 3 is 3 1/3. Well, 6 divided by 5, 3 1/3? Is 3 divided by 10, 3 1/3? No. So let's check and see if it's an inverse variation. 3 times 10 is 30, 5 times 6 is 30, and then 10 times 3 is also 30. So in this case, the first example here is going to be an inverse variation. Okay, so it seems that the values of y seem to vary inversely with the values of x. If you check each product, you get 30. The product of x times 3 is the same for all pairs of data, so this is an inverse variation. The constant is 30. So the equation would be x times y equals 30, or you could even say y equals 30 divided by x. Let's look at the next one here, okay? Remember, direct variation, I take y and divide it by x, and I should get the same number each time. With inverse variation, I should multiply the two numbers and get the same. So here I get 6 if I multiply, and 24 and, 96. So this is not going to be an inverse variation. However, if I take 3 and divide it by 2, I get 1 1/2. If I take 6 and divide it by 4, I get 1 1/2. And 12 divided by 8 is 1 1/2 as well. So in this situation, it is a direct variation. The ratio of y over x is the same throughout. And so I can say that this is a direct variation and the constant k is 1.5. So our equation would be y equals 1.5x. Those are our quick checks, and we are through. Just to summarize, with an inverse variation, x times, and that should be times y, is going to give you, let's put an S here, times y is going to give you k, the constant. That's an inverse variation. X times y gives you the constant. In a direct variation, y over x gives you the constant k. So if you think about with an inverse variation, let me ask you this. If I have 20 pizzas, no more, no less, okay, how much pizza you're going to get if there's only one person? So you take that 20 and you divide it by yourself and you get 20 pizzas, okay? Now guess what? You got 2 people coming in, okay? And so now you have to take that 20 pizzas and you got to divide it by 2 people, so you each get 10 pizzas. And then, you have that 20 pizzas, and guess what? 5 people are in. Now you're down to 4 pizzas. Okay, so you can see here there's not a constant rate of change. You went from getting 20 to getting 10 to getting 4. Okay, whereas if I said I was going to buy you each 2 pizzas, that would be a constant variation, okay? And so that graph will be linear, okay, going through 0, 0. With a direct variation, that's buying everyone 2 pizzas. With an inverse variation, it's like, you know what, here's 10 pizzas, 20 pizzas, a number of pizzas. Share it evenly, okay? And so that's where you get that curve too. It makes a big difference when you go from like 1 person to 2 people. The amount you get goes down dramatically. But then you add 20 people or 21, or the difference between 50 people and 51 people. You're not going to see that dramatic change. The amount of pizza you're going to get is not going to be as dramatic of a change with those numbers. Great job today. Hope you got this lesson. Again, you can always replay it, and I would definitely make some vocabulary flashcards for direct variation and inverse variation with the forms of them. It's an important thing to just basically memorize. Good luck. I'll see you tomorrow.